So back in 2015, 2016, we started doing some work with detection of E. coli in water. It pushed us to think about how can we use something completely different to see if it can work with this coronavirus.
I just did a little bit of reading into what the COVID-19 situation is and what the virus itself is. And we found few similarities that we could relate to E. coli.
So at the beginning, we had a problem with accessibility and expertise.
And we found interesting research articles which compared how similar the HIV virus was to the SARS-CoV-2 virus that we were going to sense.
Using that information, that's how we are identifying Dr. Almodovar.
And that was the only virus, because of my research in HIV, that's the only virus that I could provide very fast. All of the proof of concept experiments were done with HIV proteins, HIV-infected cells, and then we eventually moved into using coronavirus proteins and coronavirus-infected plasma samples.
What we are doing different is we are trying to look at the spike protein of the virus.
It basically uses electrochemical technology, which is kind of like what you will encounter in a battery. Basically, what it does is you have a probe, something that looks like a pen, okay? And what it's doing is it's going to be able to detect electrical current changes that happen when the SARS-CoV-2 is present in a body fluid.
So basically, this sensor is detecting and recording those changes in current that happens when viral proteins interact with the ions in the body fluids. Actually, we discovered that the changes in current are different depending on which virus we're talking about.
We believe it's the fastest response time sensor that exists today. We're talking about less than a second. You can know if the virus is there or not. This is extremely fast, and compared to other methods that sometimes you have to take up to 4 or 6 days to know what happened. Even though it's not manufactured yet, our calculations indicate that it will be the cheapest in the market. We're thinking that a single probe sensor, something like you could work or use at home, could cost less than $250 compared to other methods that cost $5,000.
The idea is to develop it so that it can be very small. It could be the size of a coffee machine, for example. And the idea is that the person can self-collect the saliva, add it to the machine, get the result, and it can be used either at home with one probe, or it can be mounted into a carousel type of device where companies, universities, schools can use it.
We are just looking at the positive side of things in this whole negative situation. The sense of giving back to the society is enormous. So that is what keeps us going.
One thing that is very exciting is that it's actually demonstrate how a convergence team, how people with different backgrounds can come together and become creative in this type of situation. So I think this is the future of engineering. When times like these that are needed, I believe that's when we are the most creative. And why not? From here is possible, and it will continue being possible.